Hey everybody, this is Larry. This is me going Q3 of the weekly contest for 60 minimum jumps to reach and via prime teleportation. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. And Discord's been pretty helpful. It helps me get Q4, after the contest was decided. But anyway, the way that I think about this one is, honestly, there's some prime teleportation stuff, and we'll go over the prime stuff for sure. Though maybe not in super detail because a lot of it I think is standard-ish. But in any case, the way that I think about this problem is just honestly a train station. Where's my thing? And I think there are similar problems where they literally use train stations, which is why I kind of think of it that way. But the idea here is that, okay, these are kind of array elements, right? So I just think of it as, train stations, local stops, and in between you could go left, right, left, right. And this is a standard graph problem type thing. And then now you have express stops, right? That goes from let's just say, I don't know, just say it here, or maybe another way of thinking about it is that it is kind of, so like for example, this one you could say that, oh, it goes to here, here, or ... right? And then maybe this one can go to here, right? Okay, something like that. And the problem with this problem, one of the tricky thing about this problem is that n is 10 to the 5th, probably, 10 to the 5th, right? So what that means is that you don't even have to time or space. Well, maybe you have to space if you have enough time. Well, Leetcode's computers are not fast enough or big enough in either case. So you can't do it in n squared, is my point. You can't even construct the graph explicitly because it just takes too long, right? So the reason why I kind of have this train analogy is that then now the way that I think about it is that, okay, maybe they're different trains because this is a 4 train, right? And maybe this is a 6. 6 isn't prime. Neither is 4, really, so I'm pretty bad at this. But let's say you have a 2 train and maybe a 3 train, right? Then as a result, then you could just take the 2 train to any station in one hop. And keeping in mind that sometimes you may want to go backwards, right? Because for example, maybe you start from here, you get off at this stop, you go to the left, go here, and then maybe this goes to here directly, right? So there definitely goes in both directions, and for that part you can just do a BFS. This is BFS is pretty standard. I don't want to spend too much time explaining BFS for this problem. But suffice to say that you can BFS. But the problem again is that the space is too big, right? There are too many edges. So the reason why I brought up the train analogy is that, well, now you have an express train. And the thing with this train is that you could get on any stop, get off at any stop in just one hop, right? Then what does that mean? Well, that means that, well, one is that, wow, express train, ooh. But the second thing, more seriously, is that if you kind of look at it again, right? No matter what happens, you never need to go on the same train again, right? And what I mean by that is that, well, it is what it sounds like, really. But it is that if it never makes sense in a very trivial way. Like for this, if you're at this stop and you're taking the 2 train, it doesn't make sense for you to go here and then go here, right? Like, because you can just combine them into one bigger stop or hop or whatever, right? And that's the basic thing about this problem, and there are very similar problems, maybe without the prime part, but the structure of what I just said about express trains and stuff like that, there are very similar problems on Leetcode before, and other places. It's and we'll go over the prime part again, but and the key thing there is noting that, okay, well, if you don't take all the trains again, or the express trains again, then you just keep note of it, right? Meaning that if you took the 4 train already, because this is also part of the BFS greedy idea, right? Is that, okay, well, if you already took the first, if your BFS rather already took the train the first chance that it got, if you see the same train later, it means that you could have already gotten it, right? Meaning that, for example, if I could see the 4 train on my second move, if I'm on another station, I'm on move 10, I see a 2 train, I don't go back on, because I could have got, that means that I could have gotten to my next destination much earlier, because I would have already taken the 2 train in 3 moves or something, right? You get the idea, kind of, hopefully. And basically now you could have a sort of a global state, keeping track of what trains you already minimally taken with your PFS. Okay. But jumping back a little bit, there is this prime part. This part, I don't know that is super interesting. I mean, it is one of those things where either you know it or you don't, kind of thing. It's hard to kind of prove from scratch. It's just a prime Sif. There's a couple of variations of the prime Sif. Let me actually, and this is my version. And actually, if you watch the live portion of it, I typed the wrong version. Not that I typed the wrong version, I just kind of type it in and didn't really think about it. But the idea here is that, yeah, just a prime Sif, Google it, is the idea. But there are a couple of ways to it. One is the Boolean version, right? Which is that prime sub I, whether return is prime or not. There's another one that I use here, which is, I guess, just any prime divisor, right? So basically now prime sub I gives, there's actually a structure to this, but it doesn't actually matter. You say give a consistent random, maybe just consistent divisor that is prime, right? And the idea behind here is just that, let's say you have a composite number, you have 24, so then 24 is equal to 2 times 12, and it doesn't matter which prime it is, right? Because you can also go the other path of like 3 times, what's it, 8, right? And then now, yeah, 2 times 6, and then 2 times 2 times 2 times 3, right? And this is same or similar, but, you know, in a commutable way, ... I'm not gonna write it out, but, you know, you get the idea, right? Is that as long as you have one prime, then it allows you to construct this path, right? And the biggest number in this problem is 10 to the 6, I think, right? And 10 to the 6 is a million, right? 10 to the 6 is equal to 2 to the 20, which means that in theory, the biggest number will have, I mean, it's slightly smaller than that. I mean, this is roughly, this is not precise, right? So that means that at most goes down 20 divisors, right? That's basically, the reason why I set it up is just so that you can set up as an upper bound for your analysis, right? And that's what this is what it looks like, right? This is very standard Sif-y stuff. Basically, if you have to kind of work out your invariants and such. But yeah, but basically the idea is that, okay, you're walking I is a prime, you take a walk, so then now all the multiples of I can be divided by I. And actually I kind of messed this up now that I think about it. I mean, you could go in either way. Like I said, it doesn't matter because it all goes to the same place, like in this 24. But I guess I could have done something like if prime sub j is equal to j. I don't know that it matters that much. But it just depends on, like, it gives you then ordering if you need it, if you want it, because then, because then now this would be the smallest number, but instead the way that we did it, it actually gives you the biggest divisor, which I don't know, it shouldn't matter. But this is the prime Sif, right? And then that's, you could pause this and watch another video if you get a little bit confused or just haven't learned it yet. It's not, I don't want to say it's too hard. It's just that, if you haven't learned it yet, you haven't learned it yet, right? In any case, yeah, and then the rest is just a BFS ish. I do a processing thing, and this is how I process this actually. I mean, this part is actually with the BFS, so let's bring it back to, take this to the BFS. part of the code, which we'll go over in a bit. FD is actually part of the BFS as well, so we'll go over that too. But this is actually the processing, and I don't know why I call it F. I think I just thinking of F because F for F train. It's a train here in New York City. I don't know. In any case, yeah. So then now F sub X, the X train. Yeah, contains all the stops for the X train. Is this the index? The index. Oh yeah, this has to be the index because the number doesn't do anything by itself. So yeah, and I use the set for. Oh yeah, I use the set because just to make it easier. Because for example, if you have like 24, you have a lot of 2s. You don't need to add all the 2s, right? But yeah, but basically from here we skip 0 and 1, pretty straightforward. But yeah, let's say you have 24. We'll use 24 as an example. Then now, and I guess this would be the biggest divisor. So then this would be 24 is equal to, what's it, 3 times 8, right? Or biggest prime divisor, not record divisor. So you have 3. So what this means is that put, and this is I, right? Index I. So put I on the 3 train, and then 8 is equal to 2 times 4. So put I on the 2 train, and then that's it. I mean, technically it does more, but you know, there's just more 2s is my point, right? And that's basically the idea, is that, you know, now I just kind of put these on the train. I divide it out so that, you know, this 8 goes down, and then at the very end, and I got a wrong answer for this, for not doing it rather, is that I guess by the definition of this, yeah, like if 2 numbers are the same, meaning primes can go to other primes. I don't know, I did thought about it, but I guess I just didn't read it carefully, to be frank. Meaning that if you have a 2, you could go to other 2s as well. So this is a very flexible train, very you can only get on at certain stops, but you get off in a lot of places. So definitely like almost like a jumping out of a plane, really. Maybe, I don't know. Maybe my analogies are terrible. But in any case, yeah. And then now that you have the train system set up, a lot of this is regular BFS, right? This is regular BFS. This is a queue setting up for, you know, the first node. I have FD, which is D for done. So which trains are visited, right? That's basically the idea. And yeah, we start, and this is regular BFS. We have the current index, the current stop. We go left or we go right. Make sure that is inside the bound. We haven't visited yet, or in the BFS, like we haven't yet constructed the shortest path through this stop. And if we did, then we could, you know, update the number, queue that append 1. You could also, yeah, I mean, there are a number of things. But yeah, and then now, if it is prime, and prime sub x is equal to x if it is prime, that's how I set it up. You could kind of see that I structured it here. It also means because we set it up from x to x, or x to max, from x, we set up x from 1 to max for a big number. So that means that if this is untouched by previous numbers, then it is a prime. So if it is a prime, which is what this means, and that we haven't visited this train yet, that's what FD is set for. So if this train has not been visited yet, well, 1, we visit it, and then 2, we put all the stops that are in the station. We just do a regular check. This is, yeah, regular BFS stuff now, right? We just make sure that X is the stop, BFS stuff, and we're Gucci. And that's it. This is going to be linear time, linear space-ish. I mean, there's this prime CIF, obviously, which is like its own thing, like O of M log M, if you want to say M is the max number, or maybe you could talk about it in terms of number of bits, which is like B times 2 to the B, maybe, if you want to think of it that way. But yeah, and yeah, and I say ish, linear-ish, because this prime thing, you could add each number can have at most, I mean, I said 20 earlier, here because it's like just an easy upper bound, right? But you can imagine that if a number has 20 prime 20, it's fewer than that because they have to be distinct. But let's just say for the purpose of hand wavy math, which is b 20 digits or bits of 0 to 20, that means that for each number there are only 20 different trains that go here other than the left and right. So that means that for each n element, each of the n element, there are most 20. It gets visited, like this loop does 20 times on the other side of it. So as a result, the complexity for this one is over b times n, where b is the number of bits. So yeah, that's it. Cool. I think that's it. Yeah. That's all I have for this one. Let me know what you think. Yeah, thanks for watching. And I think that's it. Yeah, you can watch me solve it live during the contest. Now, I'm like, maybe I think I should have tested that case literally, or close to it. But sometimes happen. That took 6 minutes. I didn't think I was that slow. But these days I am a slow old man. Okay, Q3. Minimum jumps to reach n via prime teleportation. Nums n start at 0 and go to n minus 1. Okay, you could go left or right. Okay, prime. If num sub I is prime, from any index that j is an I, because they're not prime. Okay, so it's just about constructing graphs. I don't know why they don't do this in a better way. This is kind of dumb. 10 to 6, like it's the same problem. They change it to 10 over or 10 to the 5th. But yeah, and I still write it out. Good. The prime sif. You get time. Right. Okay, but that's not quite. I mean, that's fine, but we probably have to do a little bit better. We might have to make modifications. I can't just template it in my head. Or maybe I could just copy and paste it if I'm going to template it from my head without thinking. But 10 times each number does 10 steps or whatever. 6 was 10 to the 6 again. 10 to the 6 is 20, right? 2 to the 20. And so like 10 steps each. Okay, fine. So if you're all on a prime, you could go anywhere else. Okay, right? Not the other way around. Easy mistake. I forgot how to write this. Actually, I don't know. I mean, it's fine. Maybe this is fine too. Okay, that's all I need to change. I don't know how to change 0 and 1. But not primes, but maybe just primes. What do we have? Okay, maybe I have to just special case it. Alright, so you would... Oh, I was gonna say you would only jump to the right, but that's not true. So, okay, just buffer search it. Why? I think I was trying to be too clever on things. Just buffer search it, that's fine. Right. Something like this, right? now we can either go -1 or +1. So okay, and then now we have to do the prime jump thing, right? Okay, we should probably pre-process the other way, right? Okay, fine, yeah. Nope, if it's not a prime, then yeah, then start at the number. The two things we have to do. Okay, so then, okay, that's fine. That's fine. Then now we have a, and we don't always want to go to the max, so we have to actually store it. Okay, fine. I just call the way that I think about these problems is this particular structure setup is that I think of it as a train. If that makes sense. I guess let's use a set, right? Well, it's not a prime number. We go right, and then now f of yep. Let's say I for index, right? Is that right? So we get the indices, and this is an add. This is a set, and then now we want to say fd is equal to I don't know, just I guess a set, right? Now we take a train, right? So then now, oh no, this is right. So then if prime sub now is the index of num sub now, if prime sub num sub now is not num sub now, then yeah, we go on the train. And num sub now, not in fd, then fd dot add num sub now. The reason we do it this way is so that you don't check it every time for all the loops, because then now for x in f sub prime sub num sub now, this is a prime, right? No, this is wrong. Oops. That's why. So if it is a prime, and it is not, we haven't visited yet. FD is like F done, and F is the F train, is how I think about it. Okay, so for every stop, we just go, right? Yeah, that's the index. Yep, okay. Is it always possible? It is always possible, right? So yeah, what was it called? Best. 2 and 3. Hopefully, did I mess something up? Is it infinitely looping? No, this should only happen once. I mean, this may be slow if we don't do this correctly, but this should be correctly. Right. 1 plus 1. That's weird. What am I infinitely looping on? Oh, 1 is weird, isn't it? Because this is, well, no, this will always be wrong, so we don't ever jump on 1. And 1 is not a prime. What is going on? What am I appending? I update, append, huh? Right. Oh, is it here? Actually, okay, so maybe that's where I was wrong. Okay, let's see, what am I doing wrong? So, while prime, while this is not a prime, we don't have by this biggest prime, right? Okay, let's see. Where did I mess up? Maybe I rushed it. Output limited, please. Oh, -1. Oh, because you go to 1 and then -1. Okay, this is awkward. It's 0 possible input. 0 is not possible. At least they caught it for me. So I mean, because it would be really sad if it'd be really sad if you know, we did it later. Okay, this is way wrong for some reason. But yeah, yeah, a lot of debugging today. I mean, the algo is fine, but the implementation maybe not so fine. 1, 2, we still go to 4 by going to +1, right? Why are you not visiting? dx now is the index. So why is this not working? 2 goes to, I mean, nothing else. This should work, right? Now plus tx, now plus tx. Oh, now plus tx. Yeah, okay, well, there you go. 3, 3, 4. I mean, it's wrong, but maybe I'm just off by 1 number of jumps. Why does this have? Was it? Why is best of 0? Best of 0 is, oh, I just set it to 1. I was like, why is this 1? Alright, 2, 2, 3. Okay, where's my print statement? Let's get rid of it. Where's my print? Oh, there it is. Alright, not a hard problem, but a dumb problem for me. I mean, and doubly so now. 757 expected is 1. 7 to 7? I guess so, huh? I didn't think about that. I mean, I think I just didn't understand it correctly. I mean, I guess that is, like, you can jump from a prime to any other prime, or the same prime, right? So I guess that's the thing, and we explicitly do not do that. So yeah, okay, I guess I just didn't consider it. It's fine. The problem still stands. Yep. I add it? Attempted. I mean, just like whopping in your face. No silly mistake, please. Ah. Oh. Wait, why? 5. It goes to 3 and 5, right? Oh, because it doesn't do the last prime. I am a silly boy. I am a silly boy. Okay, and then now I guess we can actually take this out. Man, I am a silly boy. Silly boy. Unexpected. Okay. I mean, it's hard to be excited when, you know, you made 2 silly mistakes that, you know, on a problem that you know should be able to do. So really no bueno. Oh, but still top 26, not bad, I guess, considering I guess they remove a bunch. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, do your mental health. I'll see y'all later and take care. Bye bye.